All right, so this section is going to be 8.3 partial fractions. Had a little bit of frustration with making this video. Of course, you will feel none of that, but created it twice now and something occurred. So it's my third time, hopefully third time's a charm. But the idea behind partial fraction decomposition, notice the word decomposition, talking about breaking down. If you think about the decomposing of anything, is breaking down. So we're talking about breaking down fractions. So let's look at 3 over x minus 4 minus 2 over x plus 2. Now, bringing them together is what we've normally done. If we want to subtract these fractions, subtract these rational expressions, the first thing you want to do is find your common denominator. That's x minus 4 times x plus 2. Then from there, you're going to multiply top and bottom of each fraction based on what's not in your LCD. What's not in your denominator from your LCD. So here, x plus 2 was not in this denominator, but it was in the LCD. So we multiply top and bottom by that. Here, x minus 4 was missing. So we multiply top and bottom by that. Then we do our distribution of the 3, distribution of -2, combine our like terms. And then that will give us x plus 14 over x minus 4, x plus 2. So that's not the new thing. But what it is that you will be given this fraction and you would be breaking it back down to the fractions that actually came together to give you that one. So you're decomposing a fraction or decomposing a rational expression to get the first expressions that you had that came together to get it. So that's what we're doing. So we're going to actually take this one and break it down to see how you get these two back. All right. So let's try it out. Directions would be find the partial fraction decomposition of x plus 14 over x minus 4, x plus 2. All right. So the way we'll set this up, x plus 14 over x minus 4, x plus 2. We take it to x minus 4 and x plus 2, separate them, and over each one of them, put a constant. Normally you start with A, then you go B, and if you have more, C, D, and so on. So we just put in A and B. We do not know what A and B are, so we're going to go through the process of finding that. So this is your initial setup. You take each one of the factors from your denominator, separate them, A over x minus 4, B over x plus 2. Then from there, we're going to multiply each numerator by the LCD. So let me remove these slashes. So we multiply each numerator by the LCD. So your LCD is supposed to be this denominator right here. So you're just going to take that and multiply it to each numerator, which is what we did here. And what's going to happen is that the next move would be for us to reduce. All right, so reduce. Notice that both of these cancel in the first term. X minus 4 cancels here. X plus 2 cancels here. All right, and that will leave us with x plus 4 equal to A times x plus 2 plus B times x minus 4. All right. So now at this point, what the book leads you to do in each case is to set up a system of equations like we did in a previous section. So I'm going to show you another way that you can do it that actually eliminates the forced system of equation setup. You don't necessarily have to do it. This is just a different way. To me, it's easier, but it's up to you. In one of the examples, we're going to have to use a system of equations. So you'll see the complexity of that one in a second, about third or fourth example. But here, what we would do is look at each one of our parentheses and say, what can I plug in here to make it go 0? So in the first one, plugging in -2, -2 plus 2 would be 0. And in the second one, plugging in 4 right there, 4 minus 4 would be 0. Okay, so those are the values that I'm going to use to plug into my equation. So looking at the first one, I plug in -2, and I plug in -2 in each place that I see x. So -2 plus 14 is 12. -2 and -2 cancels here, it cancels out that whole thing. And then here, -2 and -4 gives you -6. So now I have 12 equal to -6b. divide both sides by -6, and I have b equal to -2. All right. Now we do the same thing, but with 4. Plugging in 4 in each place that I see x. 4 plus 14 is 18. 4 plus 2 is 6. And then here, 4 minus 4 is 0. Cancels out. And that leaves me with 6a equal to 18. Divide by 6. And a is equal to 3. So now that we have, oh, I almost lost my pen. So now that we have a and b, we go back and plug it in here where a is and where b is. And that will be my answer. 3 over x minus 4 plus -2 over x plus 2. And then if we were to match it up what we originally did, go back here. That's the same thing that we have right here. Okay, so you have broken down or decomposed that expression. All right. All right, so let's look at the next one. Here we have x minus 18 over x times x minus 3 squared. And so this square matters. And so the way we'll break this up is this way. If a over x, b over x minus 3. And because the square is here, you do have to do x minus 3 and then x minus 3 squared. So make sure you notate how you would break it up. Because if it was x minus 3 cubed, then you would do x minus 3 squared, then x minus 3 cubed. So you have to have each one, each of the next one, in each of the next power in your progression. So, yeah. So notice we put an a, b, and c over each one respectively. Then from there, just like we did before, and I'll remove these slashes. We're going to multiply each numerator by the LCD. Once again, this is the LCD, the original denominator. And things are going to cancel for us once we do that. So I'll put my slashes back. All right, so here we see that all of this cancels, leaving me with just x minus 18. Here, x cancels, leaving me with a times x minus 3 squared. Here, only one of these x minus 3's cancel, so that leaves me with bx times x minus 3. And then here, the whole x minus 3 squared cancels, leaving me with cx. All right. So then I'm looking at what can I use for x that will create 0 to cancel out some terms for me. I see that 3, plugging in a 3 right here, going to cancel that out, and then plugging in 0 right here. So start off with 3. So that's 3 minus 18, a times 3 minus 3 squared, b times 3 minus 3, and then c times 3. All right, so those 3 minus 3's will cancel or turn into 0, so they cancel out the a, b terms, and that leaves us with just c and 3. So it just gives us what? 3c equal to -15. Then of course you divide both sides by 3. C is equal to -5. All right. Do the same thing with 0. Plugging in 0, that's 0 minus 18. A times 0 minus 3 squared plus b times 0 minus 3 plus c times 0. So those back terms, b and c, will cancel because of the 0. And that leaves me with a, well, -18 equal to a times -3 squared. Of course, -3 squared is 9. -18 equal to 9a. So then we divide both sides by 9, and a is equal to -2. All right. So now we can go ahead and plug plug in A and C. So we got C right here and A right here. All right, because we still need to find B. We do not have B. So what we can do is just plug in everything that we do know. And so that's why we plug in A and B, A and C. C was -5, A was -2. Now that we've plugged in A and C, now we can just let X be anything. So you choose, I always want to choose something easy. I chose +1. Now, of course, you don't want to choose what we've already plugged in for X. Remember, we plugged in 0 and we plugged in 3. So we don't want to use either one of those values. So I chose just +1, something easy. So now that you plug in 1 everywhere you see X, B is the only term that you don't know. So you would just solve it out and then solve for B. Or simplify and then solve for B. So negative, well, 1 minus 18 is -17. Then inside the parentheses right here, 1 minus 3 is -2. Here we have 1 minus 3 is -2 as well. And this is just -5. This is going to turn into -2 times 4. That'll be -8 minus 2b minus 5. Combine your like terms, -8 and -5 is -13. So I have -17 equal to -13 minus 2b. Add 13 to both sides. Now I have -4 is equal to -2b. Divide both sides by -2. B is equal to +2. So now we have a value for A, B, and C. And that's our result. Go back to what your original setup was. Right here. Oh, still have my eraser on. So right here. And then you put A, B, and C in accordingly. So that's what we did right here. All right. Keep wanting to say, did anybody have any questions? So used to that. So next scenario, I believe is our last one. Next scenario is your quadratic factor. When you have a quadratic factor, in other words, your denominator has x squared or your variable squared. So that's not spell it. Denominator. So variable squared is in your denominator. So this is how you would set it up. Remember before we just did A or B or C or whatever, but notice we have AX plus B. We have to go one variable power lower than what we have down there in the denominator. Trying to see. All right, so that's how you would set that up. So let's look at this next one. I didn't do this well enough. I didn't leave room. Is there a way I can create room? Nah. Okay. So just going to do this first and I'll put it back. So this is our original equation. They want, not equation, but expression. They want us to break that down. All right. So the way we'll set this up, as a matter of fact, I'll do it like this. So we set this up this way. So we'll do a over x minus 2. And then the x squared plus 2x plus 4 is not factorable. So we will set it up like we talked about here. doing bx over c. Notice we didn't do a over b because we used a already, so we don't want to repeat the variables. So you start with the next one over, that's b, so bx plus c. It's okay, you know, you can use many variables as you want, capital letters, and those we're using capital letters in our numerator. You can go to, you know, all the way down the line if you need them. Okay. So that'll just set up for that. Then the next move, going to multiply by the LCD, and I ran out of room because screen is not as big as I would like, but our denominator, LCD, is this, like I said before, what you originally had. So then you multiply each numerator by that LCD. So that makes all of this cancel, leaving us with just 3x squared plus 17x plus 14. These two pieces cancel, x minus 2. And so that's just a times x squared plus 2x plus 4. And then this cancels, and it leaves you with bx plus c times x minus 2. All right. So that is this right here, the result of your denominators canceling out. Now from here, we want to go ahead and distribute and expand what we have. So we'll take the a, distribute, take the bx, and then the c and distribute it. And so that gives us this right here. So 3x squared plus 17x plus 14, that's okay on the left side. Then we have ax squared plus 2ax plus 4a plus bx squared minus 2bx plus cx minus 2c. So now here, because we have a lot of stuff going on, we really don't have much of a choice but to set up our system, and you'll see how we'll work it in a second. So we're going to set up a system by matching up the powers of the variables. So I tried to color code it. So the purple are my x squareds. So notice I have 3x squared equal to axb squared, ax squared plus bx squared. So that's what I have here. Those are my x squared. As a matter of fact, I can do this too. Those are for my x squareds. These are for my x's. And these are my constants. Remember, your constants mean no x, no variable at all. Try it one more time. Yeah, it's good enough. All right, so you see how color coded in my green, my linear terms, the x terms, 17x. Then I had 2ax minus 2bx plus cx. So that's why I have those in green. And then the blue, 14, 4a, and then minus 2c. All right, so now notice what I did here. This green expression or green equation has a, b, and c in it, right? Now this first one has a and b. The third one has a and c. So what I did was I took the first and the third one, the purple and the blue one, and then solved them and wrote them in terms of a. So in other words, I solved this one for b so that it be described in terms of a. So b is equal to 3 minus a. And then for the third one, the blue one, I wrote that in terms, I solved it for c. So you can say c is equal to minus 7 plus 2a. So both a and b, not a and b, but b and c are written in terms of a. All right. And then here, so that -2 goes to each term. So that's why that happened for us. So we have b is equal to 3 minus a, c is equal to -7 plus 2a. Now we can plug them in right here for b and c, and the only variable we have is a to solve for, and that's what we needed. So we plugged in b right here, and then we plugged in c right here. So you see we have 17 equal to 2a minus 2 times 3 minus a plus negative 7 plus 2a. Go ahead and do your distribution. Don't forget to distribute negative 2. So that's 2a minus 6 plus 2a, and then minus 7 plus 2a. Combine your like terms, 2a, 2a, 2a gives me 6a. And then negative 6 and negative 7 is negative 13. So now I have 17 equal to 6a minus 13. Add 13 to both sides. Then divide by 6, and a is equal to 5. Once we have a, we set ourselves up to be in a great place because now we have a. And remember, b and c are written in terms of a. All right. So now I can just plug in a and find b. So that's 3 minus 5, which would be negative 2. And then negative 7 plus 2 times 5, negative 7 plus 10, and that is 3. All right. Once you have A, B, and C, that was what we were looking for. And you go back to your original setup, which is here. So now you plug in accordingly for A, B, and C. Oh no, give that back. All right, there we go. So plugging in for A, B, and C. And there we go right there. So it's C, B, and A was green. All right. So try these out. See if you have any problems. See if you get stuck with anything. As always, bring them to class and we'll knock them out or shoot me that email. And take care.